I don't think, because unless we sell the others, aren't there? I think there's some in here. I did. I think there's some in there. I think there's 2 or so in there. Sorry for the delay. I think we're ready to start. I'm just waiting for a little signal to say, yeah. Okay. Okay. Today we're covering the introductory chapters of the Universal Model in Volume 1. There's the introduction, methods and models and pseudo-theories, the dark age of science and scientific revolutions. So that's what we're trying to cover today. And then it goes into 5 science chapters, all about the Earth system, the magma pseudo-theory, the rock cycle pseudo-theory, the hydroplanet model, the universal flood model, and the weather model. And then Volume 2 is the living system, and Volume 3 is the universe system. Volume 1 is out digitally, but not in print, but should be by the end of the year. And Volume 3 is still in progress. Okay, that's a little more detail on what we're covering today, and then a little more detail on the science chapters. And so my name is Allan Wade, and I'm very happy to be here, and I'm glad you're all here too. And we've got some people, we are trying to stream it live on the internet, so hopefully some people will jump on there and get to see it on YouTube as well. Because I had a question on Facebook asking me if they, because they're in Canada, they're saying, well, when can you get up here and do a presentation? So best I thought we could do is do this streaming it live. So anyway, this is the name I came up with. It's kind of convoluted, but it takes a little piece out of each of those 4 introductory chapters. Objective models from dark age to revolution. So we're going to be covering the unique learning process in the scientific dark age from chapter 3. And then chapter 4, the crisis in science allows the claims and demonstrated evidence of the universal model to start a revolution. So that's kind of what we're talking about today. Any questions? All right, let's keep rolling. Oh, okay, so this is chapter 1, and there are sub-chapters that are listed right in the front of each of those chapters. And so I have those here, and we'll kind of talk about them. So the first main point, I think, is the answer principle, that answers come from questions. And questions are very important, and so FQs is what we call fundamental questions. And so sometimes you'll see that little FQ, or having a green line up here says that it's something from the universal model. If I have a blue line up here, it's a quote. Okay, and I want you to think outside the box. And I don't know how many of you are familiar with this little puzzle. Let me go ahead and pass these around. And you can get out a pencil or pen and try them out. Okay. I got a couple of copies for you so you can try it. I recommend to my students, okay, if you already know the answer, then actually, if you already know the answer, what you should probably do is try one with 4 by 4 instead of 3 by 3. And you get, I think you only get 1 more line, maybe 2. So, get outside the box and try to draw those straight lines so that you intersect all of the dots. Okay? And I'm going to let you go ahead and play with that, and I'm going to keep going because we got a lot to cover. Do is, because if you aren't familiar with this, I think you should have several tries to. So how do we question? There's actually 4 different attitudes that he talks about. There's the critical, but that's fault finding. There's the skeptical, but that's doubting. Partial, but that's prejudiced. And there is objective. And that's where we really try to avoid our biases, because we all have biases. We all have things based on the way we're taught or raised, our experiences in the past. We develop biases, and if we can question things objectively, we'll actually look at it, try to step outside ourselves and our own experiences, and try to really look at it and question it personally. Any questions about that? I think that's a really good point that was explained very clearly. And it gives the foundation of where we're going from here. In fact, he comes up with a word for it because he's saying we shouldn't be skeptics or critics. He calls it an objectic. So he recommends that we are objectic as we look at science. Okay, this quote from Sir Isaac Newton, he says, "I'm a friend of Plato, I'm a friend of Aristotle, but truth is my greater friend." So we can best accomplish an open mind, that objective viewpoint, if we have an agenda of truth. Right? That should be what we're striving for. That's what we really want. And the hard question principle is that hard questions are easy when you know the answer. Right? Like you know the answer to that 9-dot puzzle. It's easy, isn't it? Once you know it, once you've been exposed to it. Okay? But struggling to learn things, first 3 laws that are identified in the universal model. The law of knowledge, wisdom, and intelligence, respectively. And you can see how they all tie in to this learning process and why that's so important. Okay. When someone answers a question about the foundation of a subject, it can change everything we know. So we really have to start asking these questions, and that's really what the universal model is doing, is it realize, there's a lot of truth that is not clear in science, and so the universal model is trying to come up with those natural laws and it's asking those questions that are producing a change, and we'll talk more about that change as we go through here. So the definition principle: if we don't say what we mean, we don't mean what we say. Again, simple statements, but they're really powerful because they're principles that give you a foundation. Everyone will set a goal, and the goals stimulate questions. He gives an example of people setting goals like, finding a new job, or even something as simple as getting a drink of water. Okay, and you start asking questions. Then, well, what kind of job do I like to do? Where can I get the training for that? All right, stimulates questions. If I want to drink, where's a cup? Right? Maybe a simple question, but it's a question you got to ask if you're going to achieve that goal. So the questions are important, the definitions are important, but one of the problems is we don't even really have a good definition of truth. In fact, he went to the dictionary, right? We think, well, it's got to be in the dictionary, right? So this is what he found when he went to the dictionary to find the definition of truth. It said that truth is a fact, real, and actual. But then you look up fact, and that's truth and reality. And you look up real, and that's true and actual. And then you look at actual, and that's real and fact. So he realized that it's a tautological thesaurus list, okay? Which basically means they're just using other words to describe the exact same thing, and they're really not giving us any more information about truth than we knew before, right? They're just saying it in a different word, and you can't say it's wrong because it's another word for the same thing. But it's not giving us any enlightenment, any information. So it's a problem. Truth, so he starts to explore truth and explain it. And he says that truth implies involvement with the future, right? Those other three don't imply something in the future, but truth does. And so the time is the test of truth, because truth is not only factual and actual and real today, but it's going to be that way in the future. So he defines truth as a knowledge of what is, was, and will be. Because that relates to that unique quality of truth that says it's not only what is right now and what was in the past, but it's also what will be in the future. And he points out the founding fathers of our country that said we hold these truths to be self-evident, right? So there are some truths that are self-evident, that should be obvious, that should be accepted as true and accurate based on just by themselves, because that's the way it should be, I guess. Here's a self-evident principle. It is because it could be no other way. Okay, and so that's why I ask you to do the experiment with the cube, right? What did you find out? Because he points that out as an absolute truth that a cube has how many sides? 6. Okay? And if you have two hands, a right hand and a left hand, that we can accept. It was true 500 years ago when they thought the earth was flat. It's still true today. Do you think it's going to be true tomorrow? Or 100,000 years from now? Yeah. Okay? So that's one of those absolute truths. He also mentions that there's water in a living, including in archaeology, is whether or not the world can be known or understood, including our own existence. So this professor is sitting in front of him telling him this, right? So they're there together like brains in a jar on some shelf, you know, because it's kind of that idea like it's shown in the Matrix. That how do we know what's real, right? Okay. So, so the science teacher that did not exist, okay, questioning whether anything can be known. Okay, here's another one. And I guess it's a problem in two ways. One, because scientists are questioning so deeply, right? But I've also been saying how important questions are, right? But you know, questioning our own existence is a problem, because I mean, then what is real? I guess. But we do want to question, right? But we need to question in a reasonable way, right? So let's be objective and let's question objectively, but let's not go to an extreme where we're questioning our own existence. Then this is an aragonite crystal, which I kind of think of what he was talking about, like the ping pong ball over a blow dryer. Only this was being pushed up so that it was suspended above one of these hydro fountains of water, getting stirred up. Still under 5 miles of water, but getting pushed up so that it's not growing off of a rock. See, if you look at all around that, there's no attachment point to a rock. So it was suspended in the water as it was forming and growing. The other thing I should mention on that piece of sandstone that we're passing around is we put a torch on one corner, and so it's melted and has formed a glass. And if the entire Earth was a big ball of magma, then we would be walking on glass. But crystals form in water. So that's a big difference, and you can see it with that piece of sandstone. Okay, thank you very much, Michael. I should also mention Michael Spencer is the son of the founders of American Family Education, and I want to thank them for letting us use this building. I've actually had the privilege of teaching here at American Family Education for 3 years, and to have great students like Michael in my classes. You can see he really learned some stuff and is continuing to learn more. So I'm really proud of him. And you can see how some of those basic things, some of the experiments that have been done in the universal model do give us a lot of information and help us to understand how simple things are formed, like sand. So anyway, let's go on to methods, models, and pseudo-theories. This is chapter 2. A natural law is a statement of truth. And the sad thing is there's no single set of steps that constitutes the scientific method. Rather, there are different traditions in different scientific fields about what is investigated and how. So, and it actually took me a long time, because I'd been teaching science before I found out about the universal model, and so I had a system that had, I think, 13 steps in my scientific method, and it took me a while to catch on, but he's got a better system here. If anyone offers conjectures about the truth of things from the mere possibility of a hypothesis, I do not see how anything certain can be determined in any science. So that's Sir Isaac Newton, and yet today in science, we're really stuck on these hypotheses, these theories. If we stopped doing experiments, we would no longer be doing science. And so that's why the YouTube channel that we're streaming this to is Do True Science. And my Facebook page is Do True Science, because I think experiments are not only the fun part of science, but also essential for the discovery. And it tests our understanding, right, if we can make a prediction about what's going to happen. So where is the standard or universal scientific method? Unfortunately, the universal model comes up with a new one, and it's the one that they used in all of their discoveries. So ours actually starts with theories up here, and then we have predictions, then testing and observation, and finally evaluation and natural laws. And it's kind of neat. I kind of had a hard time adjusting to this at first, but it really kind of came together for me when I realized that it also ties back into the whole learning process, which makes a lot of sense. And I actually started to color code the different areas of it, because the theory and prediction is something that is intangible and basically comes from inside us, like our own intuition, right? We have to come up with that idea. So it's an intangible asset that comes from our mind. We come up with an idea or a theory about how things work, and then we have to make a prediction. So if I understand this right, then I should be able to predict what will happen if I do this experiment. Does that make sense? Okay? So that's a really important part, and yet it is intangible. And so it's kind of over on that intuition side of things. Okay? But once we do that, the theory and the prediction, once we have that, then we come back over here for testing and observation. And that's where we're doing the experiment, right? We're using our 5 senses, as well as that sixth sense of logic and reason to test and observe and really figure out and measure what's happening. Then, once we have that physical side of it, and we're answering those questions from our learning model here, right? What, where, when, who, as well as our understanding of how and why, then we're putting that together now to evaluate both sides. You know, did our prediction turn out correct? And what did we find from our testing and observation? And with that evaluation, then we can decide if that is a new natural law or if we need to go back to the drawing board. Right? And once we have that, then the truth is explained, right? Because the natural law is a statement of truth. Okay? Any questions about this? Because this is really new stuff if you haven't read the UM already. Okay? So natural law is a statement of truth. Natural law, a predictable effect from a stated cause. Cause and effect. Okay? And it's predictable because we've done the experiment already, and now we can predict what's going to happen. Okay? So the universal model is kind of like a map. They're both organized representations of facts that can be demonstrated and explained the truth about the world around us, right? Because we can drive on that road that goes over to Los Angeles, okay? And it helps us if we're looking and following the map, right? So, but in the universal model, we call them models. Now, sometimes models include cars, trains, other things to represent the world around us, the way they give us perspective, and a framework that allows us to observe in new ways. Right? Get it down to a size that we can really look at it and explore. Right? And the more correctly a scientific model describes nature, the more simply we can understand and explain the portion of nature that that model describes. Okay? So part of the problem is that science today is ever looking, never expecting to come to a knowledge of the truth. And pseudo-theories are false theories that are taught as fact. And the universal model is a verifiable model that teaches facts. Okay? Like the relative sizes of the planets, pretty dramatic differences, right? A lot of times they're pictured very differently. So that is the end of chapter 2, and I'm noticing that it's 8 o'clock. So do you want me to try to rush through chapter 3 and 4, or should we postpone it to next time? What do you think? You want to rush through them? Okay, we got a little more time? Okay. All right. All right, it sounds like everyone wants us to go ahead, and I'll just kind of quickly go through the rest that I have here, and I can probably do it in less than 15 minutes. Okay? Okay, so chapter 3 is the dark age of science. And science is a study of demonstrated truths and natural laws that describe and explain nature. He goes through and looks at various scientists. Nicholas Copernicus, he identified that the sun doesn't revolve around the earth, that the sun, the heliocentric solar system means that the sun is in the center of the solar system. Galileo knew astronomy and developed a telescope, looked at the craters on the moon. Johannes Kepler had the 3 laws of planetary motion. Robert Boyle, air pump, pressure, and gas volume helped our understanding in those areas. Sir Isaac Newton with the law of gravitation and the laws of motion. Made a huge difference. Okay? And then so those are some of the big scientists that actually did experiments and really helped and expanded our understanding. And he throws one other in here as an American scientist, actually Noah Webster, known for writing the dictionary because he had to define a lot of scientific terms. And so it was a really worthwhile effort that he did. Then, using this book, 100 Scientists Who Shaped World History, we identify and categorize all the way back from 500 BC up through the centuries, 1700s, 1800s, 1900s, to 2000 here. And so through the centuries, we identified all these 100 scientists, and we categorized them in 4 different categories. And let me go to the next slide because you can then read it. There's new observations, new technologies that they invented, new theories that they came up with, and new laws that they discovered. And what's interesting is I go back to this, you'll notice from 500 BC to the mid-1800s that there was no theories. All of the theories were tested and either became natural laws or they were discarded. But, and so we have, during all those thousands or hundreds of years, well, thousands, 1800, right? Nearly 2,000 years, we have all these scientific laws being developed. But then we get up here around 1850, when we have Charles Darwin with his theory of air evolution, Louis Agassiz with the Ice Age theory, right? And these theories are being held on to. We can't prove them correct, and they're not becoming natural laws, but we're still holding on to these theories. And so that's why we claim that we are now in the scientific dark age, and have been in the scientific dark age for at least 100 years, because there have been no new natural laws, no new scientific laws set forth by scientists over the last 100 years. And I mean, the first time you hear that, don't you just kind of react like, really? Like, oh, wow. And so this is the big picture of modern science. We start here with nothing, and then we have this big bang that produces all of the molecules, right? Now, where I come from, if you have nothing and something appears, right, that's magic, right? It's not science. It's like hocus pocus. And, but, oh yeah, that's a solid cane there. Okay? But, oh, too much banging around. What did I do? Hopefully that'll go. Oh, good, it went away. Okay, but anyway, that's what science, modern science is claiming, that, oh, gotta get back to presentation mode. I hit the wrong thing. Where is presentation mode here?
Right there, so you see the little button kind of near the clock. A little
Down.
left.
Too
far. Right.
Okay, come.
Warm.
Here?
Cold. Keep going too warmer.
Oh, right there, slideshow. Okay, sorry. Thank you. Okay, that's going to come up with it, I hope. Sorry about that. Okay, got to be careful what I'm pressing here. Okay, thank you. He's letting me use his computer for this, so that's why I'm not familiar with. Oop, okay, here we go. So, from nothing, everything is produced with this explosion And somehow that explosion, and I've never heard this to happen in real life, but this explosion organized everything into solar systems that are all revolving, and all of the chemicals that perform exactly the way those chemicals should perform. And then there's another leap here that these chemicals somehow come to life, and then all that little bacteria that was the first cell of life evolves into all of the plants and all of the animals and eventually apes, and that somehow evolves into us. So that's why we claim it is a pseudo-theory. We don't agree with it. And yet there are scientists that are saying there will be no great revolutions in the future comparable to those bestowed on us by Darwin or Einstein or Watson and Crick, who did the DNA. Is modern science fulfilling its purpose, or is it time for a revolution? And so chapter 4 is scientific revolutions. And it goes through and talks about the Copernican revolution that changed the world's paradigm by displacing the Earth from the center of the universe. The Newtonian revolution, which revealed new laws of motion, gravity, and changed our paradigm with respect to light and the solar system. And so usually when you think about the progression of science, most people think that it's progressing a little bit at a time and just going up steadily. But what this chapter points out very clearly is that we have a paradigm, and that paradigm is held on to for a long time. And then all of a sudden something changes revolutionary, like these changes where the Earth is not the center of the universe anymore, right? And even the sun isn't, right? So everything changed when that happened. So it's a revolution. And it changes our paradigm, our way of thinking. And then Newtonian revolution changed everything about science as well. And then there's the chemical revolution, and there's 3 different scientists that were particularly involved in that. They changed the paradigm of air and water by discovering many of the elements, the molecules, that are so important in our chemistry. And helped us start discovering how those molecules and atoms interact with each other. So, did everything really come from nothing? And basically we're saying that because this paradigm, this way of thinking has been held on to for a long time, that we're really ready, because there's a crisis, that we're ready for a new revolution, because all of the textbooks need to be rewritten with a new foundation. I mean, don't you want your family to learn truth? So that's what we try to do here at American Family Education. And the experiment that Michael Spencer mentioned is this one here. And although this comes in a later chapter, I thought I should point it out, because hyperthermal quartz growth, where we took a quartz crystal and nearly doubled its size in a day by having it in the right conditions, and he already told you hyperthermal. We couldn't find the right term in science. There wasn't a word for it. I mean, you've heard of hydrothermal, but you need the pressure, because the amount of pressure that you have to have is 13,000 pounds per square inch. Okay? So to get 13,000 pounds per square inch of pressure, how deep does your swimming pool have to be? I mean, I recently did the calculations, and it's 5.5 miles of water, which means there was a time when there was 5.5 miles of water on the surface of the earth, so that quartz crystals and sandstone could be formed. But that means that, like, this is a piece of petrified wood, and if you notice, the wood is the darker area, and there's white quartz around it. This kind of milky white is quartz, and the bark then on the outside. So I'll pass that around, and notice that's about a square inch. There had to be 13,000 pounds of pressure to force the silica-rich minerals into that piece of wood so that it could start crystallizing into stone, into quartz-based crystals like little geodes, all the cells of the wood changing to little geodes. So to us, that gives us scientific proof that there was 5 miles of water above the surface of the earth, and that's how petrified wood was formed. That means all petrified wood was formed 4,363 years ago when the flood happened. And because that's the only time in history where there was 30,000 feet or 5.5 miles of water to create that 13,395 pounds per square inch of pressure. And with the plate tectonics all moving these plates, creating volcanic activity, there's plenty of frictional heating going on as the continents sank 5 miles. And so this quartz growth experiment teaches us how rocks are made, that rapid growth can happen in the right conditions. The new terminology, hyperthermal, the amount of pressure equals the 5.5 miles deep. The hyperthermal environment and geological is geothermal. There's evidence of the marks of the flood, sandstone and petrified wood, and even fossilized dinosaur bones. Those bones were turned to stone 4,360 years ago when Noah was on the ark, our ancestor. He's my 103rd great-grandfather. Changes geological time and the age of the earth, and it changes every field of science. All of the science books have to be rewritten. And I'll pass around this rock here. This is a piece of man-made quartz. Okay, so we made it in 15 minutes, like I said. But you will want to look that out. So I'm open for questions. If you have any questions now, I can take those.
I have questions.
Yeah.
About, before the flood, and the earth must have looked a lot different.
Yeah.
So if I remember Dean saying it just said they're just like little hills or something like that, or the tops of the mountain or something.
Maybe, yeah. So there's no fossils found in granite. And so granite is actually that original rock that formed the earth. And so it would be interesting. I think, Google has Google Earth, right? And they've done the moon too. I think we need to go and look at where the granite is on the earth and have Google map it out so we can see kind of where that is. I think that would be fun. Yeah, it'd be very interesting. Because, theoretically, we could kind of get a picture of that. But it would be under the coal deposits and the salt deposits and a lot of all the sandstone deposits, right? I mean, you can look down in the Grand Canyon and there's dozens of layers of sandstone, but in the bottom layers, it's granite, and you can look down and see it. So, good question. Yeah.
I attended a lecture by a preeminent dental. He was a dentist who would go around giving continuing education, and he said the biggest thing he can think of that proves the existence of God is just the teeth in the mouth, and the placement or the utility of each one, and the number coming in at the right times. Says, how could that possibly have been, evolved?
Right.
Crazy, just with 32 feet.
Yeah, and I was thinking, why would you put this soft tongue right next to teeth? Right? How would that happen naturally without, or accidentally through evolution, right? Good question, or good comment. Okay, any other questions? There are some books in the back as well as rock kits. The rock kits explain different rocks and kind of how they're made and where you can read more in the UM about them. And there's also a summary book. So if you're interested in that, And I really appreciate you coming and staying the whole time and paying attention, and thank you very much. All right. Thank you.